Today we were using algebra tiles to model polynomials, and so they're good for modeling, and they're also really good when we start to simplify or collect like terms with polynomials or add and subtract polynomials together. So here I'm using a virtual algebra tile site, and I'll share the link to that site so that you can practice doing this yourself. And at this point we've chosen the easy level of difficulty, so you can see I've got easy chosen here, but we can go to more difficult ones later on. And we're asked in this example to model the expression 5x. So these are the algebra tiles that we'll work with. We have small squares which represent 1, and in this case the positive 1 is yellow and the negative 1 is red. We have a green tile for x, which is a rectangular tile, x, and again red for negative x, and the blue big square represents x squared, and the red tile negative x squared. So these are our terms. So the one term or constant term, the x term, and the x squared term, and we can combine those obviously together. The algebra tiles we used in class were a little bit different because they were all red for the positives and all blue for the negatives, but this is just a different representation. So we're asked to model the expression 5x, so all I need to do for that is to drag across 5 of these x's, and there's our feedback at the bottom. It shows you the algebraic representation down here, 5x. And the feedback says correct. I click new to try another problem, so I can go with new. So if I wanted to model 5, I just drag 5 of these, and in short order we see that we can get pretty good at this. Let's go to a medium level of difficulty problem. Now I'm going to try and model negative x or negative 1x minus 4 or negative x plus negative 4. So here's my negative x tile. So that's negative x, and then I have 4 of these negative 1s, which makes negative 4. Let's try another one. X plus 3, so positive x plus 3, or plus 3 1s there. So now I'm modeling x plus 3. Let's go to a difficult one. 5x squared plus 4x plus 4. So I need 5 of these x squareds. 1, 2, 3, 4, 5 plus 4x. You can see the expression building at the bottom of the screen. Plus 4. Okay, so that's how we model polynomials using algebra tiles. So here's my polynomial up here at the top, and these are my algebra tiles here that model that polynomial expression. Let's now go to something a bit more complicated, where we are now simplifying polynomial expressions. So here I am on a different page. You can see down the left hand side here we've got modeling expressions, which is what we just did, and now we're going to do simplifying expressions, and then we're going to do this adding polynomials here next. Again, right now I'm on the easy section, so I want to model 4x minus 2x. So if I take my 4x's, my 4 positive x's, and drag them across, that's my 4x, and then minus 2x. So I've got the 2 of these negative x's. So we talked about today in class this thing called the zero principle, which says that if you've got positive somethings and negative somethings, they add together to make 0. So positive 1 minus 1, plus 1 and a minus 1 makes 0, plus 1x minus 1x makes 0, plus 1x squared minus 1x squared makes 0. So if I drag this positive x onto this negative x, they cancel each other out and it disappears. And if I drag the other one onto that, now I'm left with just 2x. So 4x minus 2x makes x plus x, or 2x. So that's a simplified version. So all I'm doing there is collecting together like terms. Let's try another one. So I want 3x minus 5x, so here's my 3x. and my minus 5x looks like this. So what's 3x minus 5x? You can think about what that would be if you just stuck with the algebra. 3x subtract 5x. What does that make? And we can use the algebra tiles to help us visualize it. So there's my 3x minus 5x, and then I can drag these positive x's onto the negative x's, and they add up to 0, and I'm left with 2x. So 3x minus 5x is negative 2x. Let's go to a more difficult problem, so I'll choose medium. So I want 2x squared plus 1 plus 4x squared minus 2. This is a similar problem to what we did on the ticket today. So here I've got 2x squareds plus 1, and then I want to add another 4x squared, and then minus 4. Okay, and I can see that I've got at the bottom here 6x squareds in total, and plus 1 minus 4. So what does plus 1 minus 4 make? Well, if I combine this negative 1 and plus 1 together, they cancel out, so I get 6x squared minus 3. So if I simplify this by collecting together like terms, I get 6x squared and then minus 3. So I can model it with the algebra tiles. Let's try a difficult one. So here we have a more complicated one. So I've got 5x squareds, 1, 2, 3, 4, 5, plus 4x. There's my 4x's. And then I've got plus 3. So 1, 2, 3. Then I've got another 3x squareds. I'll put them sort of here next to the other ones. And that gives me a total of 8. And then I've got minus 4x. So 1, 2, 3, 4, minus 4x, and then plus 3. So I've got another 3 here. So I can see that when I add those together, I'm going to get 8x squareds here and plus 6. I've got plus 4x minus 4x, which is going to be nothing. And I can see that if I drag these on top of these, we don't have any x's left. So the simplified version of that is 8x squared plus 6. So that is an example of simplifying expressions. And it's just a short jump from that to go to adding polynomials. So if I click on adding polynomials, here's my two polynomials, 3x plus 2 and 2x minus 1. So I can model that if I drag my 3x's here. Is 3x plus 2. That's 3x plus 2. So I've modeled that correctly. And then I want to add to that 2x minus 1. So 2x minus 1. Okay, so it tells me I've correctly represented the problem. Now find the solution by combining like terms. So I'm going to combine like terms together. And the only simplification I can make is by adding together this 1 and this negative 1. That will make nothing. So I've got 1, 2, 3, 4, 5x plus 1 overall. So if I simplify this expression, I get 5x plus 1 as my answer. Now, as I say, you can do this without using algebra tiles for sure, but the algebra tiles help you to visualize it, and you can use them at the very least for a check. I want to try a medium level of difficulty one. So negative 4x squared minus 1, let's try that. So there's my negative 4x squared minus 1. And then I'm going to add to that negative 2x squared minus 3. Okay, now let's combine like terms. Well, they're already combined. There's no cancellations. Everything is negative. So in total, I've got 1, 2, 3, 4, 5, 6. So negative 6x squareds and negative 4. I'm going to go to a difficult one. And I'm just going to keep going until I get one where I've got a subtraction. Okay, so here's an example where I have a subtraction here. Now, I can't subtract the algebra tiles from each other, that doesn't really make any sense. All I can do is add algebra tiles. So if you have a minus sign here, or a subtraction between the two polynomials, what we can do is we can do something called add the opposite. So I'm going to set up my first polynomial over here. So there's my minus 2x squared minus 2x minus 3. And I'm going to add that to some of the tiles over here. So if I want to change this minus sign to an addition, I can do that as long as I change the signs of all of these coefficients in this polynomial here. So rather than positive 2x squared, I'm going to have negative 2x squared and negative 4x and negative 3 because of this negative sign. So I can change that to a positive as long as I change the signs of all of these. So if I put negative 2x squared, oops, and then negative 4x, and negative 3, then I will have correctly modeled this problem by changing the signs in this bracket all the way through. Now if one of these was negative, it would become positive if we wanted to change this to a positive. So it's a technique called adding the opposite. And we can see we don't have any cancellations here. These are all negatives. So we've got negative 4x squared, negative 6x, and negative 6. So that's how you can practice with algebra tiles on your computer to simplify polynomials, to represent polynomials and algebraic expressions, and also to add and subtract them.